Have you ever wondered what the two main branches of statistics are? Well, in this series, we're covering non-calculus based college-level statistics. So thanks for coming, and with the time constraint, let's get started. Before we define descriptive and inferential statistics, I'd like you to keep in mind that a sample is just a subset of the population. If a sample is sufficiently randomly chosen from a population, then it should pretty much represent the population. The first of two main branches of statistics is descriptive statistics. In descriptive stats, we're using the data to create graphs, charts, summaries, and other descriptive information. We are simply reporting what the data is, whether it be from a population or the sample. The second branch is inferential statistics. In this branch, we often use the descriptive statistics to estimate or infer things about the population. This usually means we have a sample or even more than one. So one more pass through these two terms. Descriptive statistics is more of a plug and chug process, i.e. you have data and you do very specific procedures to the data to create particular summaries or graphs or facts. Most of the time, however, we use programs like Excel or R to produce these for us. Inferential stats, on the other hand, will consist of taking those outputs, using our brains together with some super cool theoretical statistical methods, and infer stuff. Let's say we had data on a particular anti-worm medication for our new classroom puppy. With descriptive stats, we could calculate means, standard deviation, and other summary information. We could also create histograms, bar graphs, pie charts, although I don't know why anyone would want a pie chart, because they're generally useless. However, just looking at these descriptive stats doesn't really help our cause. After all, we want our puppy to be healthy, don't we? This is where inferential stats enters the picture. Using some of the techniques we will learn in this series, we can save this puppy. We could reasonably determine if the medicine is effective, or even better, we could make a better, more scientific comparison to perhaps other medicines. Okay, so there you have it, the basic difference between descriptive and inferential statistics. And while understanding this difference isn't absolutely crucial, it will help to make understanding the techniques we use later on a bit more bearable. Thanks for watching. Feel free to leave any questions or comments you have down in the comment section below. Don't forget to like and subscribe if you're into that sort of thing. And in the next video, we're going to cover some more basic and very foundational definitions. Until next time, as always, stay nerdy, my friends.
Well, your chances of getting Alzheimer's by age 85 are 1 in 10. Kind of scary, actually. The average smoker lives to be age 66. So if you were in marketing at a cigarette company, you could say, smoking lowers your chance of getting Alzheimer's. Right? Absolutely correct statement.